Greetings, dear sea lovers. How are you? We hope your winter holidays went great, as much as the pandemic situation allows at least. But here we are again, with a new episode of The Way of Learning. Welcome to our first maths lesson. Today, we will talk about symmetry. You know, symmetry is everywhere, in everything around us. We are an example ourselves. And the marine world is not excluded. But before the lesson begins, be sure to be a subscriber to our YouTube channel. It's very easy, and it will take a few seconds, but your action will be extremely helpful to our job. Click on the red button and on the bell to be notified when new videos are published. You could also offer a personal contribution to our cause. A little donation on TP will be precious to acquire professional equipment, and you will be an integral part of the project. Check the link in the description. Okay, I think that's all. We're ready to start. Symmetry, a word that everybody knows and uses every day. But what does it mean for an object to be symmetric? An object is considered symmetric if it can be divided into two perfectly identical parts by an imaginary line called axis, or, concerning three-dimensional objects, a plane. Let's take a geometric shape, for example, a square. It is pretty easy to divide it into two matching parts, and we can do that in many ways. The same concept is applicable to body parts. There are many kinds of symmetry, determined by the way the pieces are organized. In particular, in my life, we have three main types: bilateral symmetry, radial symmetry, biradial symmetry. Let's analyze them one by one. Bilateral symmetry. Organisms exhibiting this symmetry contain a single plane which divides the body into two identical halves. Imagine dividing a shark, a turtle, a whale, or why not, even salmon. If you cut them along the imaginary planes across the bodies in the middle, you will obtain two specular halves. However, each of them won't be completely equal and will possess some asymmetrical features. Radial symmetry. In this case, we have central axes or planes crossing the organism from a side to another, passing through the center of the body and producing as a result a certain amount of equal parts depending on the number of the planes. In marine animals which exhibit this peculiar symmetry, body parts are arranged around a central point, and for this reason, radial symmetrical animals do not have a distinct front, back, left or right side, but just a top and a bottom. Let's think of a jellyfish or an anemone. These are excellent examples of this type of symmetry, but they are not the only ones. Even sea urchins and sea stars belong to this group, but they deserve a separate discussion. In fact, regular echinoids, the most common sea urchins, asteroids, sea stars usually equipped with 5 arms, and ophiuroids, brittle stars, at first glance seem to possess a pentaradial symmetry, which means their body consists of 5 identical parts around a central element. Quite obvious in sea stars, but also easy to observe in sea urchin skeleton. Well, that's true, but not totally correct. This is just a secondary symmetry, due to the fact that the larvae of each group present a bilateral symmetry, and the madreporide, the structure that filters water into the water vascular system of these animals, continues to possess this symmetry even in the adult stage. Instead, our regular echinoid bodies shows bilateral symmetry, and unlike the regular ones, they possess a front and back side. Finally, we come to the last type, biradial symmetry. This is a combination of the two previous types. A biradially symmetrical organism can be divided into 4 parts along a central plane, but each of the parts is also equal to the one on the opposite side, but not to the part on the adjacent side. Ctenophores, commonly known as comb jellies, are animals that show this particular symmetry. Of course, there are also many asymmetrical animals in the vastness of the sea, which present bodies with external and regular shapes. Sperm whales are one of them. This big marine mammal has one single nostril on its upper left part of the head. That's the reason of the direction of its blow. Even the narwhal is an example of asymmetry. Its distinctive helical tusk is located in the upper left jaw, therefore dividing the animal into two not quite halves. The difference between them is easily noticeable. Not mentioning only cetaceans, sponges well represent this category of animals. They have asymmetrical bodies with unusual shapes, probably to maximize the efficiency of water flow through their body cavities. We could go on forever due to the variety of organisms we can find underwater. Each of them, if closely observed, is an example of perfection. And it's really crazy to think it's all thanks to nature. Human beings have always been inspired by nature in their aspiration to create all kinds of things: buildings, vehicles, household items, and so on. And for many reasons: aesthetics, resistance, functionality, efficiency. We still have a lot to learn from nature. Next time you find yourself underwater, try to observe the insane maths behind marine creatures. You will definitely be amazed. And you don't even need to be an ace with calculations. Thanks for watching and see you next week!